Okay, hi everyone. So I think it goes without saying that you guys can totally feel free to interrupt me. This is a very, very intimate setting. So I'm going to talk to you about expressions, which is a library that I worked on a while ago, and try and kind of explain why I worked on it. So can someone tell me what's wrong with this code? Or what someone might consider to be wrong with this code?
False data dependency. Sorry, could you maybe just repeat that back to the mic, please?
Sure, sure.
Be able to see it in the recording.
So you're saying a false data dependency between what?
You can't perform the get address operation until you receive the result from get phone. So the code is claiming that there's a dependency there when there's no actual dependency.
Okay. Right. So actually what I was kind of, okay, so that, Travis said that there's a dependency because get address, it's as if it depended on get phone, but it doesn't really. So I guess Travis kind of jumped ahead and...
Sorry.
No worries. So what I was kind of looking for here is actually the fact that these futures are not going to execute in parallel. Because when you call the function and then you get a future, but I guess that's kind of the same thing actually. And then what about now? Now the futures are executing in parallel. Can you hear me correctly? Yeah. It's annoying to kind of put my mouth in it constantly. So yeah, now they're executing in parallel, but we still have a problem. And the problem still emanates from the fact that there's a kind of a false dependency here. And the problem is that if the first future completes in 1 second, let's say, and then the second one completes in 2 seconds, and the third one actually fails after 10 milliseconds, then the following code is going to fail after 2 seconds. And in my experience, most of the time in enterprise software and just software in general, that's not what you want. You could actually make an argument that you actually want your code to be perfectly deterministic and you want to fail with, you want to look at all the things because you want to always fail with the same thing, but I think in practice most of the time, if one of the things is going to fail, most people want to know immediately and don't really care about the failure being deterministic. So that's kind of the problem. And a solution would be the following code. So we have our 3 futures this time. Now we've kind of introduced Scalaz. We're using applicative to apply the 3. We're combining them. Actually, let's say we're rendering, same idea. And now it's going to fail after 10 milliseconds. Because we're using applicative, and applicative is capable of, well, applicative basically doesn't have the dependency, right? So you're doing things in parallel. So that's a solution. But then here's another problem where here we actually have a dependency. So in order to get the address, we need the phone. And to get the spam score, we also need the phone. And so in this case, we want to go back to our for comprehension model where we have a dependency. But then there isn't a dependency between get address and get spam score. So we're still failing after 2 seconds because get address takes 2 seconds. Get spam score fails after 10 milliseconds, but we're not able to kind of address this. So this is another solution where we address this, and here we're kind of falling back to not using a for comprehension notation. We map over the phone, and we use our applicative 2 in order to combine address and spam score together. But this code is kind of, I mean, it's pretty straightforward, but it's kind of starting to be a little bit boilerplatey. And one needs to kind of think, oh, how am I going to combine these things together to make sure it behaves in the way I want it to behave? So a better solution, I think, is through expressions, the library that I wrote. And within an expression block, you can extract things that are in an abstraction or kind of like a monad. And so here we're extracting phone. We put that in P. And now we render P, we render extract of get address P, extract of get spam score P. And now this fails after 10 milliseconds. So it's pretty concise. It does what you want. So yeah, so this is kind of my motivation example because I was trying to write this kind of code that failed fast, and I ended up using Scalaz when I was solving it at my company. But I was kind of not super happy. I wanted something that you could use like a nice, concise kind of for comprehension notation, but for comprehension doesn't do this. And if you prefer something that looks a little bit more like for comprehension, here you open expression block, val p, extract, address, spam score, kind of, it looks like a for comprehension render, and this behaves the same way except that it fails fast, which is kind of what I was going for. So why exactly does this not fail fast? I will not go into the details of why that is. It has to do with monads and the way they're built. You can watch my talk at Pacific Northwest Scala 2014 in order to see that. And well, if we have times and if you guys have questions at the end, I have a few slides on it, but I'm going to skip it for now. So expressions. Expressions are notation for kind of all the things. So what are the features? It uses the least powerful interface, and so it uses applicative when it can, instead of using monad all the time. And that means that features can fail fast. It also means that you can use validation inside of expressions. It plays well with if and match statements. So this is kind of one of the reasons that I think the Scala async await project was created, is because for comprehensions don't really match well with if and match statements. When you kind of mix them together, you end up with this blob of code that's not always super readable. So it plays well with if and match statements. Unlike Scala async await, which is specialized for futures, it's a unified notation that works for all abstractions. So it'll work for I/O, for future, for task, for validation, and anything that has an applicative or a monad defined for it. And finally, it's customizable. If you don't want your futures to fail fast, you can provide an instance of applicative that does not do fail fast, if that's what you prefer. So it taps into type classes to be highly customizable. So here are a few examples. This is the failing fast kind of example that I used for motivating. So the idea is that you want to fail fast. I'll skip that because we already went through it. Interacting with if. So here we have 3 futures. The first one waits a second. The second one waits 5 seconds. And the other one waits 2 seconds. And if we do a for comprehension here, and then after that, within the yield, we do if A is equal to something, then polish B or else polish C. If A is equal to something, then there's no need to wait on C. Unfortunately, if we use it in the for comprehension, this whole thing is going to take 5 seconds because we need to wait on A, B, C before applying our operation. And we could fix this with the second version where we have nested for comprehensions, and now it only takes 2 seconds, but now we have nested for comprehensions. It's kind of hard to read. And so with expressions, you have something that's relatively close to the for comprehension notation above, but it only takes 2 seconds because it's through the magic of applicative and type classes, it kind of figures out that it doesn't need to wait on C in order to polish B because A was equal to something. Do you guys have any questions? I've been kind of plowing through. No? Okay. And so one of the nice things, obviously, like for comprehensions, this supports kind of any notation, so option, either, writer, list, I/O, task. It's fully generalized notation. And also it supports validation, which is kind of interesting. And I wrote in theory because I was working on this a few minutes ago and I didn't quite get it to work. But in theory, a really interesting thing is, so validation doesn't work in for comprehensions because there's no monad defined for it. And the reason there's no monad is because the idea of validation is to accumulate errors, and the way to do that is using applicative. And that all makes sense. And obviously, you can use validation with expression, but one could argue that it's not super useful to just use that because if you were to just use applicative with it, the notation is actually pretty decent. But you could define a monad for validation that defines app as not kind of stopping, and so accumulating errors, and defines bind or flat map as kind of stopping. And so that way, you can have this big blob of code, and if you have dependencies, then obviously if A fails, and you need A in order to produce another validation, then you won't get any errors from that validation because that validation was never able to be created because you didn't have the A. But if you have a bunch of things that are sort of independent, then you can accumulate errors. So in this case here, if we look at the content of expression, sorry, that's a little bit small, I'm realizing now. So the content of expression here, we're extracting the first validation, and with that, we are getting the third one. But the second one and the fourth one are independent. And if you were to try and do this with a for comprehension, it wouldn't work because there's a dependency between the data. And so, I mean, yeah, just validation doesn't work in a for comprehension. But here you can do it, and you'll still get the two message errors because A was a success. We computed C from A, or 3 anyway, there's 4 of them, A, B, C, D. So you get C from A, and then that one fails, and then D, which was totally independent, failed, and so you end up with a failure of both of them. So I find this kind of neat because you can work with validation, and the notation will just kind of do the right thing and find as many errors as possible depending on your dependencies between data. Yes?
I've never seen 4 equal signs. Is that what I see on that last line?
Oh yeah, so that's just because so the question is what are the 4 equal signs? And the 4 equal signs come from specs 2. So when I was writing the presentation, I just want to make sure that I'm not putting any code examples that don't actually work. So that's just like copy pasting the code from my specs 2 in the library. And 4 equals is just asserting that the 2 are equal. And if they're not equal, it'll print out saying, you know, this and this is not equal. You said it would be equal, and if it's equal, the test passes. You could write should be. It's a shorthand for should be, really. So yeah, supports validation. So how does it work? It uses Scalaz, even though it doesn't technically need to. It could use the same mechanism as for comprehensions, which is to just expect, filter, and map, and well, in this case, zip, because zip would be the equivalent of applicative, apply. So it could work in the same way as for comprehensions in order to not have a dependency on Scalaz. But right now, it kind of depends on Scalaz because it has this nice definition of all these abstractions. So Scalaz defines functor and apply and applicative and monad. And basically what we're doing is we desugar the code within the macro to use apply to, map, point, bind, all these functions. And we're very careful to use the weakest method that we actually need. Because, for instance, in the case of validation, you can define, well, you could either go the route of saying, well, there is no monad for validation, in which case the syntax still works, or you can say, here's a monad, but we're not going to just let the applicative of the monad for validation be derived from the monad. We're actually going to make sure that apply actually is implemented in a way that that supports the behavior that we want. So yeah, that's what that looks like. And yeah, so the macro is a fairly simple code transformation. So if we have ABC, and then we have a definition foo that works on string, and some of these are futures of string instead of being strings. So we just put this expression foo extract A, extract B, and really what it desugars to is a call to applicative.apply to, as we see below. And so in this case, one could argue that it might be easier to just use the applicative notation, like just use the raw applicative version is actually shorter than the version with expression, but eventually you kind of start to see the savings. This slide is just to talk about the importance of using the least powerful interface, like I kind of alluded to before. So the more powerful an abstraction is, the less flexibility you have when you're implementing instances of that abstraction. So monad is very powerful. You can express kind of any computation with monad, but it limits the it limits the flexibility when you're implementing the instance of the type class for Monad, for instance. So and you know, you guys can ask me questions or watch my other talk, but basically it's impossible to define a monad for future that fails fast. Well, actually, impossible. You can define, like I said before, you can define an instance of monad and make sure to override the definition of apply, which is normally derived from the implementation of bind, and in which case you can define a monad that fails fast. But traditionally, it's considered that you kind of can't define a monad that fails fast. So that's that. So here's an example where monad is required. So we have a function foo, which takes strings, and a function bar, which takes the string. And the function bar, it produces a string. And so our code with an expression is calling, we're extracting A, which is a future, calling bar, and then we get another future, which we need to extract again. And then we pass that into foo. And so basically, the idea is here, you need to use monad. You cannot get away with applicative. So expressions is going to convert the above code into the code that we see below, which is using monad. And in this case, once again, not a huge difference. Yes?
Sorry, what's the return type of foo?
Yeah, I mean, it would be, in this case, it would be string. Yeah. Yeah, it's too bad that it kind of got cut off. But yeah, so foo is like a normal function, and bar is kind of like one might say like a monadic function. It returns, or anyway, it returns a future. So like it's kind of putting it back in the context of a future, and you need to like extract it again. But that's obviously a good question. So yeah, and then in the case of if statements, you want to use monad. And the reason why you want to use monad is because if you don't use monad, you can't do that. You can't avoid the branches that you want to avoid. So in this case, you know, if A turns out to be true, we want to kind of ignore C. We don't care if C takes, you know, hours and hours and hours or fails. It doesn't matter because we don't need it at this point. And you need monad in order to do that, to support that. So this is an example of where monad is more powerful. So we need to use it. But the trade-off is that the person implementing bind is less flexible than apply, so we won't be able to fail fast on it. But that's fine. That's what we want. Then we have our match statement. So a match statement match statements are actually kind of the trickiest part of implementing this macro. This is a fairly straightforward match statement, which kind of looks almost like an if, and so the transformation is the same. But Scala has this concept of a stable identifier in a match statement. So here, foo y is it's not saying, oh, okay, because normally if there was no backticks on the foo y, it would be saying match on anything and bind the value of extract bar to foo y. But in this case, because of the backticks, what we're saying in the case where extract bar is equal to foo y, which is a previously defined value, then do this. And I don't think this is a feature of pattern matching that's used all that much in Scala, but if this macro is going to support all the Scala language, it kind of needs to support this kind of thing. And as you can see below, like kind of the desugared version of that is a little bit more involved. You definitely don't want to like write that on your own. And then if you have two of them, it just gets even worse. So there are some similar projects out there. And so one of them is effectful. So effectful, the stated goal is to be kind of like async await, but generalized to any monad. So it's very similar to this one. The disadvantage is it doesn't choose monad or applicative. It always uses monad. So it doesn't support the idea of failing fast. It doesn't support validation in a nice way. And that was kind of the reason why I worked on expressions. Then there's another project, really interesting project called Scala Workflow, which actually is extremely featureful. It supports nested abstractions. It supports the use of the weakest abstraction. But unfortunately, it uses untyped macros, which have kind of been abandoned. in Scala 2.11. And so the project is kind of just like being left there right now. And to be fair, also because it was using untyped macros, the macro is really complicated, and it was kind of reinventing the wheel a lot. And it kind of re-implemented scoping instead of letting Scala C take care of that. And because of that, it had very limited support for like the entirety of the language. So, so yeah, I think it was, in some ways, it kind of was a dead end. But anyway, we'll see if untyped macros become a thing again, and if it proves possible to. I'm not sure about that approach. So after seeing it, I still thought it was worth kind of putting energy into my own project. And then finally, async await, which has the advantage of being, I guess, a SIP and like the most popular, most well-known one. But I kind of think that it would be unfortunate if async await kind of, well, anyway, I don't really know. But it strikes me that async await is specialized for future when you can make something that it could support, task and all these abstractions. So, and plus, async await, I'm not sure it's like built on sound principles, because the implementation seems like this big black box. I'm not sure, and it can actually support other futures, but you need to implement this huge interface, which kind of strikes me as odd when we have this nice kind of category theory defining applicative and monad with very minimalistic interfaces that allow you to do whatever you want. And is already fairly well known. So it strikes me as odd to have this weird kind of like huge definition of what a future is, and you need to kind of like jam your thing into this. And plus, I did tests, and it doesn't fail fast. So for us at the time, it was not an option. And I don't know, probably it's possible to make it fail fast, it just doesn't. So limitations of the current project. It actually supports a bunch of stuff, like, well, obviously, just simple function application, that's like the first thing. If-else statements, function currying works, string interpolation works, blocks of code with value definitions work, basic match statements work. So yeah, the big problem is match statements. There's a lot of match statements that match statements like get desugared already by the compiler into this like really complicated thing, and it just makes it really hard as the implementer of a macro to kind of like deal with it. And then pattern matching in a value definition actually desugars to a pattern match. So that's where it kind of starts to break down if you have complicated pattern matches. And so when would you want to use expressions in your own code? So I believe that if you're writing kind of this big block of asynchronous code, like your typical like backend to a service, where you're doing a lookup to get a, in this case, like a phone and address, all that kind of stuff, whatever, or tweets and stuff like that. And you just like you have all these asynchronous functions, and you just want to like jam them together and render them whenever they're all done. And if one of them fails, like kind of like the most like straightforward case, then I think it makes sense to use expressions because it's just going to do like the right thing. And it's like low, like it raises kind of the level of abstraction where you don't need to think, oh, do I need to map, or do I need to flat map, or do I need to apply, because it's just like compose them in the most like straightforward way, and I'll do that for you, which is nice. And kind of the same thing if you have these, in this case it's option instead of future. And the idea is, we have a match statement, we have if statement. If we would try to do this with a for comprehension, it would kind of start to break down because, for comprehensions expect this kind of linear thing. And here we have a bunch of options because we're using a JSON library, like the Rapture JSON library. And when you do as string, depending on your mode, it returns an option because maybe that, maybe fruits on the JSON was not a thing. So all these are options. And we just deal with them as if they weren't options, and the whole thing is going to return option, and you kind of don't need to think about it too much. But it's not like a full-blown replacement for comprehensions. So this is an example taken from Remotely, which is an open source RPC that I worked a little bit on. And here we have an example of a for comprehension where we call task.delay on system.current milliseconds. So this is a function time, which takes a task and produces a new task, which is going to produce the same result, and a duration, so how much time it took to produce that task. And we implement it with a for comprehension, we do current millis, then we execute the task, and then we check the current millis again, we subtract the two. Pretty straightforward. And in this case, as Travis pointed out at the beginning, there's kind of a dependency in the order. So for comprehensions, they're very good at sequencing things exactly. In practice, we use them for a lot of cases where we don't, and that's kind of where I think expressions comes in. But in this case, we actually really want to make sure that we check the time, we execute the task, and then we check the time again. Were we to try and do this with expressions, it would kind of magically, but it's not magic, it's very principled based on, but it would say, hey, there's no dependency between task and T1, so let's do them in parallel. And so possibly you'd end up with the task saying that it took 0 seconds, even though it might have taken 5. So definitely, if you need precise sequencing of stuff, then you want to use for comprehensions. But in all the other cases where you just want to jam things together, I think you'd be better off using expressions. In terms of future work, it would be nice to work with Skala Meta, because right now macros are kind of a pain. It would be really nice. Oh, so this actually improves Scala check function generation. I didn't update the slides, but I'm pretty proud of my test suite. I probably have like a humongous amount of, well, a lot of tests that basically say, and uses Scala check to say, given like these 3 options of something, and given arbitrary functions on them, expressions should always give the same thing as what you'd expect it to be desugared to, and that's kind of nice. It gives me a decent amount of confidence into. Yes.
Could you just take a minute to talk about Skala Meta?
Yeah, sure. So Skala Meta is kind of the it's a project to kind of give a facelift macros in a future version of Scala. It wants to kind of define its own version of the AST, and one that's, I mean, obviously, Eugene would be better at explaining it, but I'll try and. It kind of wants to define its own AST, which is like nice to work with, because the AST of the compiler, which is kind of the de facto AST right now, it's optimized for performance, and so sometimes it's a little bit less, it's not safe by construction. So like you can construct ASTs that are going to be like rejected by the compiler because they don't make sense, but you can construct them, so it's not type safe in that way. And also the type checking kind of mutates the trees, so it's not perfectly immutable. And so Skala Meta wants to define a kind of this like third-party AST, which is safe by construction and immutable, and then all the tools like macros and IDEs and any other tool that needs to manipulate an AST can use this kind of safe AST, and then the Scala compiler trees can kind of implement their own version, kind of like, yeah, anyway, like plug into that and say. So yeah, it's basically, yeah, I don't know if that helps. Okay, kind of fumbling here. Anyway, so Scala check has, if you say, given a function, in the current version, it generates you a constant function. It's not able to generate an actual kind of arbitrary function, which kind of reduces the amount of confidence I have in the test, because there's a lot of arbitrary functions doing things that might expose bugs in my thing where constant functions would appear to work perfectly. But luckily, there's been kind of a renewal in work for Scala check to support generation of arbitrary functions, which is really nice. Another thing I'd like to do is implement context manipulation. That's something from Scala workflow, where sometimes inside of an expression, it would be nice to kind of just add something to the monad, depending what it is. So if you're doing logging, say at this point you want to add logging. I think I might have a quick example of that on the next slide. Supported nested abstractions, that would be really nice. Potentially that could get rid of the whole monad transformers pattern. Because if expressions had good support for nested monads, then one could get rid of all the boilerplate that kind of tries to address that problem. But I don't know if that's possible. We'll see. Obviously fix the known limitations and generalize the tests, because right now I would like to say for any abstraction that has a monad and any function and any initial value, this should hold true. But right now I kind of have to hard code it to option, because Scala check doesn't work at the type level, if you will. Like it won't generate random types to like test your function on. This is just what I meant by context manipulation. So here we're using the writer abstraction. So 8, we're saying this is a magic value, and then random, I'm a random value. And then within our expression, when we're manipulating this stuff, we want to say that if b is equal to 0, then we want to just like log the fact that we avoided a division by 0, yay. Else do a divided by b. And so, because the point of expressions is to kind of unwrap us from whatever abstraction, in this case writer, and we can deal with values as if they were actual like kind of primitive values. But within that context, it can be hard to kind of get back to the context of writer. You need to kind of do 2 for comprehensions or 2 expressions. If within an expression you have this kind of magic context thing that allows you to kind of, at that point, just stick something into the context, whatever that context is, it would be nice because then you have just one like expression, and you can arbitrarily kind of go in and out of the context. So yeah, thank you. Do you guys have any? Yeah, sure.
Does that work with the reader monad?
It should. I don't know if I have explicit tests with reader, but reader, I mean, it's a monad, so it should work, yeah. Oh, so the question was, does it work with the reader or monad? And the answer is, in principle, it should work with any monad. It's a generalized notation. Yes, Travis?
Do you see, so what would the advantage be between this approach and the macro that takes a for comprehension, identifies the dependencies, and rewrites them using an applicative operation? So it's similar, except
Yeah.
that would allow you to reuse your for comprehensions.
So the question is, what's the difference between this approach and an approach where the for comprehension is within the macro, and then the definition macro kind of rewrites the for comprehension. So I think there's like 2. So the first element is, unfortunately, as a macro implementer, you don't get the for comprehension. You would get the flat map and the map, but there might be like tricks to try and figure out that it is a for comprehension, or maybe that's fine. Maybe the fact that you receive a flat map and map, you can kind of still rewrite at that point. I'd have to think about it. But it's definitely an interesting remark, because I actually think that this macro does kind of 2 things, and they don't need to be coupled. The first thing is it does the same thing as async await, which is to say sometimes for comprehensions break down with if and match. So it does that. And then the second thing is to kind of use applicative when it can. And I don't think those things necessarily need to be coupled. They're just coupled at this point for simplicity, because a def macro was kind of the simplest thing to do. But definitely, yeah, that would be an idea, because conceivably one could want to mix kind of sequencing precisely things with not sequencing precisely. And I thought about that, like, is there a way that it could be kind of more unified? So yeah, definitely, good question.
I've done this in a rough proof of concept, and I haven't pushed it through to something that I would be comfortable using. And so I was wondering, would it make sense for me to use something like this, or to continue the process of making my for comprehension rewriter work perfectly?
Yeah, that's an interesting. I mean, maybe we should have a look at it together. And yeah, actually, there's another project that I didn't mention here because I didn't have time to update my slides, that came out from some people in Japan. They wrote a post on Scalaz mailing list. I forget the name of the project, but yeah, everyone seems to be writing kind of macro DSLs to kind of like make it simpler to work with monads. It's interesting, yeah. At first, maybe I would have kind of focused on another project had I known that everyone wanted to, but it's kind of an unsolved problem. So yeah, we should like have a look at it. Any other questions?
I have one other question.
Sure.
So a lot of people do object to having a monad where the apply
Yeah.
is inconsistent with the applicative. So we actually do this in production in some cases, and I've never actually seen real problems with it. And so I was wondering, you obviously have cases where you are using a monad for validation that is inconsistent with validation's applicative operations. Have you seen actual problems with this in practical usage?
So the question is, some people object to an inconsistent, a monad where the implementation of apply is not derived from bind, so thusly probably inconsistent with bind. But it is possible to define this in practice, to kind of override the version of apply to not be dependent on bind, which allows you more flexibility. And so are there gotchas to that? What's the reason for people kind of objecting to that? I'm not sure. For validation, I just like did that right now. I didn't even really get it to work. I think it'll work. But I have put this with future and production, and I haven't run into any issues. I don't see any fundamental reason why it's not possible to do both. So it would be a good question to kind of ask these people why this is an objection. Cool. Thank you.